Hello Rosenbergers, long time no see. My last video was on the displacement vector in 2 dimensions. Pretty useful thing, but the position vector is in many respects much more useful. This is the big problem that I had yesterday. Watch this. Hello Chief, my car's broken down. It's not working. Now at this point the chap simply wanted to know where I was. So I told him, and that was fine. Now, but then it occurred to me later on, what if there was no landmarks round about? What if it was in the middle of the sea? What would I have done then? That's a different problem. Now this is the planet Earth, you see, a nice great big globe. And this is how the position vector shows how to find each other if we've got a problem at sea. First of all though, you notice I've got the valve of the Earth here. All positions have to be measured from an agreed spot. We just call that spot here just now. It doesn't matter where it is, nothing never ever has to go there, but we do have to measure our positions from there. So suppose we've got an ocean liner up here, and we've got a yacht up here. The ocean liner will have a position vector along there, and the yacht will have a position vector along here. Okay, so if the yacht has a problem, it will communicate that problem to all the ships and boats round about it. Now if the only ship close to it is over here, can't see it, remember this might be 40 to 50 miles, you can't see it. The boat, by using positions, the boat can actually know, the ocean liner will know what path to take to get to the stricken yacht. And let me show you how we proceed with that question there. And this is our situation. This is our stricken yacht. This is our ocean liner. The ocean liner has received a signal from the yacht, some coordinates, and it's worked out the path it has to take in order to get there. Now, how did they work out that path using vectors? Well, first of all, we have to have a position which we all agree everything shall be measured from. This is a position vector of the stricken yacht, and this is a position vector of the ocean liner. And we imagine superimposed upon that a grid. And there's a grid there. And you can see the position of the ocean liner is coordinates 5, 5. That simply means it's went 5 units x, which is east, and 5, 1, 2, 3, 4, 5 units north, which is the y direction. Similarly with the yacht's position is position 3, 3, 3 units west and 3 units north, and the unit can be 20 miles, 30 miles, whatever, and that is our. Now the question is, how do we find out what this path is using vectors? And that will be the next part. Now this is the vector diagram we need to solve our problem. Let's look at this one at the top left first of all. A typical vector diagram for displacements. Easier to see vector diagrams initially as displacements. This could be a liner, for example, going in this direction here. The ocean liner changes direction and goes in along here. So it ends up here. And this is its displacement vector is from where it started to where it ended, and that's this vector here. This is called the resultant displacement vector liner because notice we've got 2 heads here and 2 tails here, and it's drawn in a slightly different way, dotted in black in this particular case. And we can say vector A plus vector B is equal to vector C, our resultant vector. Now, but that's not the same as our situation in at C. Here we've got this is our actual situation now. This is the position vector of the liner. And this is the position vector of the stricken yacht. So clearly the liner has to go in this direction to rescue the yacht. But the problem is that this is not a resultant vector, because although we've got two heads together, we do not have two tails together. So this is not a resultant vector. Now what we can do, we can take this vector here and put it head to toe, but these are vectors of different things. This is the liner, and this is the yacht. So that doesn't make any sense. So it's best to keep it like that. But now we have to ask ourselves, well, what is the resultant there? How do we make sense of the diagram? Well, we think of it. Let's look for a resultant here then. Clearly, I've got two heads here, and I've got two B's here, two tails here, I should say. Which means I can now see it from the point of view of the liner. Liner takes this path here, then this path here. It's at the exact same position as the stricken yacht. So we can read it from the point of view of the liner, then it makes sense to look at head to toe vectors. Now if I change the vector diagram to reflect that, then I've got my path of the liner, path the liner has to take to get to the stricken yacht. And this is the stricken yacht here. And it just so happens the diagram now is A plus C is equal to B. Now we know what B is because the liner, the yacht, has communicated its position to the liner. So we know what A is and we know what B is. We don't know what C is, but C is equal to B minus A, that holds. What does this mean? Well, if we know the coordinates of A, and we know the coordinates of B, subtract the coordinates of A from the coordinates of B, and we've got the coordinates of C, and that's the path we will have to take when we convert those coordinates into vectors. Simple enough to do that. And here's our final vector diagram. Let's just ties it all up now. I've put in north, east, south and west just to show, that's what we normally speak about when we're navigating, and we know that as vector C, the path we wish to take is in fact equal to B take away A that we have just shown. Now these numbers here are the components of V, and these are the components of A, and these are the components of C. For example, -3 means 3 units west. This means 3 units north, 5 units east, 5 units north. And when we subtract them all, -3 take away 5 gives you -8. That's 8 units west. 3 take away 5 is -2. That's 2 units south. So the components of vector C, the path we wish to take, should be 8 units west and 2 units south. And that matches up. Look, 2 units south, 1, 2, 8 units west, 1, 2, 3, 4, 5, 6, 7, 8. And that is how you do problems like that. Now, where is this position here when we're talking about the real planet Earth? Where is this position? Because this position is known for every single body that moves across the planet. So where is this? But to understand where this is and its significance, we have to go to London. And it just so happens I'm going there next week. And I'll be able to tell you all about this point on the Earth here.